Hello everyone, this is Muhammad Javed and it's my first lecture about the number system. And today the topic is rationals and irrational number. Okay, the rational numbers. The numbers which can be fractions of any two integers are called rational numbers like 3:4. It can also be written as 3 divided by 4. So this is called a rational number. We can take different examples like 7 by 5, 9 by 4, 6 by 2. All these can be written in the form of fractions, so all these numbers are rational numbers. There are also different categories to check either a number is rational or irrational. Let's take a look of them. Okay, the first one is fraction. As I already told you, if a number is the fraction of two integers, then it is called a rational number. The next category is the whole number. All whole numbers like 1, 2, 3, 4, 5, all these are the rational numbers. The next one is the terminating decimals. Okay, now if the number is in the form of decimals like 3.156, here we can see after 6 there is no number, means our number is terminated at 6, so such numbers are called terminating decimals. Okay, the next one is repeating decimals. If in the form of decimals a number repeats itself like 1.666 and so on, as you can see here 6 is repeating itself, so these such numbers are called rational numbers. The next category is about perfect squares. All perfect squares are rational numbers like square root of 4 is equal to 2, and we can write the 2 as 2 divided by 1, so it is 2:1. It is also a ratio of two numbers, so this is also a rational numbers. Okay, so all perfect squares are rational numbers. Now comes the category of irrational numbers. If a number is not a fraction of two integers, then such numbers are called irrational number. The next category is non-terminating decimals. Okay, as I already told you, this is the terminating decimal, so it is a rational number. But if we have a number like 3.19453 and it is continuously going on, it is not terminating itself. Okay, so these are called non-terminating decimals and it is a category of irrational number. And next comes the non-repeating decimals. Okay, if a number is such that it doesn't repeat itself in decimal places like 3.159634557, you can see here is not any periodic repetition of number 1596344. No number is repeating itself. Okay, so all such numbers are also called irrational number. The last category is not perfect squares. As I already told you that square root of 4 is equal to 2, this is a perfect square. Okay, square root. Okay, but if we take square root of 2, it is not a perfect square root. Okay, so this is a irrational number. Also the square root of 5, it is also an irrational number, and all the square roots of prime number, they are all irrational numbers. Let's take the help of some more examples to clearly understand the idea of rational and irrational numbers. Okay, here you can see 3 by 4, it is a ratio of two numbers. Okay, similarly 2 minus 2 by 3, 4 by 9, 2 by 7, 56 by 9, all these are rational numbers. Then comes the category of whole number. You can see 2, 4, 7, 15, 35. These all are whole number. Again, we can write these numbers in the form of fractions. Here you can see 2. We can write it 2 divided by 1, 2:1. Okay. Same 4 divided by 1, 4:1. Okay. In case of 7, 7 divided by 1, 7:1. 15, again 15 by 1. We can also write 15 as 45 by 3. Okay, this is also equal to 15. So this is a ratio between two integers. Similarly, 35 is also an rational number. Okay, if we have a number in the form of decimals like 0.25, we can also write this number as 25 by 100. Okay, here we can see it is a terminated decimal. Okay, again we can see here 5051 divided by 25. If we solve this division, then the answer is 202.04. Here you can see it is a terminating decimal. Okay, so it is also a rational number. Okay, now this is the category of repeating decimals. Here you can see if we divide 5 by 3, then the answer is 1.666 and continuously going on. Here 6 is repeating itself. Here if we divide 5 by 3, 3 1 times 3, so remainder is 2. Here is a decimal place and here is a 0. Now 3 6 times is equal to 18. Remainder is 2. 2 is again less than 3, so here is 0. 3 6 times 18, remainder is 2. So this will continuously going on. So our answer is 1.666. Here 6 is repeating itself, so this is a rational number. Same is the case with the 7 by 3, 95 by 15. The next category is about the perfect square root. Under root 4 is equal to 2. Okay, and 2 is a rational number. 16 under root 16 is also is equal to 4 and it is a whole number, so this is also a rational number. Same is the case with the 25 under root, 36 under root and 49 under root. Okay, so these are some examples of irrational numbers, like under root 2. Under root 2, 2 is a prime number. Okay, and the square root of 2 is not perfect square. Okay, so this is an irrational number. Again, the square root of 5 is also an irrational number. A very interesting example of irrational number is pi. Pi is equal to 3.14159266535. Here you can see there is not any periodic repetitions of number. Okay, so this is an example of irrational number. 1.414235 and continuously going on. Here you can see this number is neither terminating, okay, nor there is any repeating decimal, so this is also an example of irrational number. So this was all about rationals and irrational number.